So moving on to the back side, a piecewise function should have been a comma right there, not period, sorry. Or better said, are pieces of more than one function together in one graph, okay? The notation is something like this. So we're going to have f of x, that's just the name of the machine, and the machine has certain conditions. You're going to use this part of the machine if your input happens to be between -2 and 0. You're going to use this part of the machine if your input happens to be greater than or equal to 0. So this looks really confusing. This is the first time you see it. I hope everybody's paying attention and understands it this first time. So this is what you got to imagine, that we said f of x is the same thing as y. Imagine y equals the top one, which is -3x minus 4. Okay, and let's actually graph that. How do we graph that, guys? Where do we begin? -4, put a dot right there, and then what? What's my slope? Okay, -3/1. So you would actually go down 3, 1, 2, 3, and then over 1. Now you see how you'd be off the graph? So what we're going to do is use that pattern, but backwards. We're going to go over 1 this way and up 1, 2, 3. Over 1 this way and up 1, 2, 3. And let's put a dot right there. Let me do it in red. And let's continue to go up or over 1 this way and then 1, 2, 3 using the slope pattern backwards. And that is a good enough line. Actually, let me just keep going. Over 1 this way and up 1, 2, 3. That way I'm all the way to the edge. Okay, now here's the deal. If I had this equation, I would draw a line through it with arrows and I'd be done. But it says if your domain is from -2 to 0. So it cannot be -3. It could be at most -2. So you don't want this dot up here. Okay, so we're going to erase that part, right? So if you were to have drawn it with a pencil, what you want is a piece of this line, not the whole thing. That's why it's called piecewise functions. You want a piece of this line. And what piece is it? It's from the input, or from the x value of -2 to 0. So I'm going to erase from left to right all the way to the -2, erase. And I also want to stop at 0, so I don't want this part either. Okay, so there's my line segment from -2 on the x to 0 on the x. So this is the only piece of the line, no arrows, because arrows means that it continues forever. Does that make sense? So we don't even want this dot up here. Scratch that out. Okay, so that's the piece of the line that we want without arrows. Now let's go to the other equation. The other one says 2x plus 3. Imagine y equals -2x plus 3. So that one crosses the y-axis at 3. So you put a dot at 3. And then you would go down 2 over 1, down 2 over 1, down 2 over 1. You could extend it as long as you want. However, we need to look at the domain, which is the condition of x. It says x is greater than or equal to 0. So here's the x value of 0. So that's good. We're starting here, and it's going in this direction. Okay. So it is greater than or equal to, so you would put a solid dot right here at 3, and it is going greater than in this direction, so you'd put an arrow that way. Okay. Now, I did make a mistake on this other line because it says that it's between -2 and it has a solid dot at -2, and it's less than 0, not less than or equal to, so this should have been an open dot right here. Okay, so it's an open dot down here, and this is a solid dot up here. So open down here, solid up there. Okay. So based on this graph, if I told you find f of 0, if I told you find f of 0, which means plug in 0 and see what you get out as an output, what would your answer be when you plug in 0? 3. Here's 0 on the x, and this is an open dot, so it wouldn't be -4. It's actually up here, the solid dot, the 3. So if you were to plug in 0, now let's say I did tell you to plug in 0. And let's say you didn't see this graph, so you'd use the f of x function. So where would you plug in 0 to? Would you plug it into this input up here or to this input down here? It all depends on the condition, on your domain, on the piece, right? So it says 0. Well, 0 doesn't satisfy this because 0 is not less than 0. But right here, 0 works. 0 is greater than or equal to 0. So plugging in 0, it'd have to be with the bottom piece of the function, right? If I told you find f of 5, where would you plug in 5? Into the top one or to the bottom one? Bottom one, because 5 is greater than 0, so you'd plug it in here. If I told you plug in or find f of 1, which one would you use, the top one or the bottom one? The bottom one, because 1 is greater than 0. What if I said f of negative 1? What if I said find f of negative 1? Then you'd use the top one, because negative 1 is between 0 and negative 2. Okay? Now, if you plugged in negative 1 into the top one, negative 3 times negative 1 is positive 3, and then positive 3 minus 4, that would give you a negative 1 as an output. So for the input, negative 1, you get the output of negative 1, correct? But looking at the graph, at negative 1, the y value is negative 1. So you could get the answer negative 1 that way, or you could actually plug it in and work it out. All right, let's move on to the domain and range part of this piecewise function. So does this graph exist over here at the x value of negative 4? Nope. At negative 3? No. At negative 2? Yes. Does it exist at negative 1? Yes. At 0? Yes. At 1, 2, 3, 4. And notice that it has an arrow, so it's going to exist this way forever. Okay? So the domain is going to be what? X is what? X is... It starts right here at this value, and it continues in this direction forever. Okay, so it can't be all real numbers because it's not at negative 3 or negative 4. From negative 2, and it goes which way? That way. So what does that way mean? Greater than. And it is greater than or equal to, because this was a solid dot right here, because it says or equal to right there at negative 2. So x is greater than or equal to negative 2. That's your domain. Yes? How about your range? Well, your range are your y values. And where's this graph at in terms of y? Is it at 4? Is it at 5? Is it anywhere up here in the positives? No, it starts here at 3, and it doesn't matter which one you're looking at, all of it is below this value of 3. So what's your range? At 3 or below, what do you say? Less than or equal to 3. Can you state the piecewise function that represents the following graph? Hint, use y equals x squared for the parabola part. Okay, so let's state this. And we have this area down here. What do you guys want to call this? F of x, g of x, h of x? G of x. Sure, why not? Let's go g of x this time. G of x equals, and then we're going to put this like weird bracket type of thing. And obviously, we're going to have to put 3 different functions. One function is the parabola. One function is a straight flat line that's horizontal. And one function is a linear equation that has rise and run. Yes? So you got to look at each of these 3 pieces. From left to right, what do we have? Do we have a line? No, we have a parabola, and I tell you use y equals x squared for that parabola. Okay? So we're going to put, now remember the g of x is really the y. So we're just going to put the x squared part. Okay, so we're going to put, the first thing we're going to put x squared. But it has to have a condition, because the parabola doesn't go forever in both directions. It only goes from here that way forever. So it actually stops right here, the parabola. So how could we describe this, this domain from here that way forever in terms of x? Less than or equal to? Perfect, perfect. So what we're going to do is say x squared if x is less than or equal to 1. Perfect. Okay, now let's look at this next piece right here. This is a super tiny piece, but this piece is a piece of a line. What is that line? It's this one right here. I mean, you could visually see it, imagine it. What is that line really? Anybody know the equation of this line? Do we say x equals 3 or y equals 3? Y equals 3. Okay, so right here, this is really the y. The equals, what am I going to put here? Just 3. So everybody put just a 3 right there. Now, of course, we need a condition because this is only a piece, right? It's a very small piece. It's from here to here. And on the x's, that's your domain. From here to here, what is that? From 1 to 2. Now, how are we going to write that as a compound inequality that has an open dot here and a closed dot over here? We're going to put the smaller number on the left side. So let's put 3 if we have the 1 and the 2, the x in the middle. The open dot is going to be a less than symbol. The solid dot is going to be a less than or equal to symbol. And now for the final piece. We have a line right here. Now you could imagine it extending all the way this way and it would cross the origin right here at 0 and continue this way, right? But we don't have the whole line. We only have a piece from the 2 on greater. So the question is, what function would this line be? Y equals what? Y equals mx plus b. What's the m? 1 over 1. Okay, so m is just 1. And what's the b value? Where would it cross the y-axis if I were to extend it? 0. So this equation of this line right here, it would technically be y equals x, right? Plus 0 if you want. But we wouldn't even put the plus 0. We would just say y equals x. I mean, imagine that. It would go all the way this way to the 0 and continue going this way. But we don't have the whole line. We just have a piece of it. So how am I going to represent this function? Whoops, the y equals x. We're going to put y equals x, right? G of x is the y, and here's equals x. Now we need a condition. If what? If x is what? Greater than 2. So let's put if x is greater than 2. And we have written our perfect g of x piecewise function that represents this graph. Let me tell you, this is one of the hardest parts of chapter 2. This is the hardest part of chapter 2. Okay? The only way it gets easy is if you practice. The more you practice, the easier it gets. Now, state the domain and range. Okay? So, bless you. What do you guys say the domain is of that visual graph up there? X is all real numbers. X equals all real numbers. Why is that? Because we know that it continues to the left forever. I mean, it'll exist at -4. It'll just be way up there off the graph. It'll exist at -5. It'll be way up there off the graph. So it does go this way forever. And this line, it really does go that way forever as well. So the line exists at 5 just up here. The line exists at 10 just up here, right? So the domain, the x values really are all real numbers. Now let's go for range. The range values are your y values. So where is this entire piecewise function at in terms of the y number line? It's above 0. So how do we say that in terms of y and with inequalities? Y is what? Greater than or equal to 0. Okay? This whole thing is at 0, it exists at 0, and it's at 1, at 2, at 3, it's above. Now if you're thinking, wait a minute, it's not here, there's a gap. Yeah, but there's no gap over here. So it exists at 0 and above. Okay. Let's try to state the piecewise function of this simple graph. So let's call this one f of x. We called the last one g of x. Let's call this one f of x. Now let's put the equal sign and let's put some funky brackets, pretty big ones. How many different functions am I going to have on this piecewise function? 2 different ones, that's right. It's pretty simple. The first one should be, from left to right, should be this line right here. Could somebody give me the function of this line in terms of y equals mx plus b? Let's pretend that it actually existed all the way up here. What would that line be? What would this line be? It would be y equals up 1 over 1. So that'd be a 1x, and you don't even need to put a 1 in front of it. And the b value is 0, so you could put a plus 0, but you don't even need the plus 0. Does that make sense? So instead of saying, let me erase this part because it's not really there. Instead of saying y equals x plus 0, I want to say f of x equals, and what am I going to put up here? Just x. And now we need an if part, the condition. If what? We have to look at it with what domain? If x is what? Is this on a certain side of x or on a certain side of x, x is what? Less than 0. And it's an open dot, so it'd just be a less than 0. It's to this side of it, not to that side of it. So if x is less than 0. Now how about this other one? Let's do it in blue up here. This guy, that's a totally flat line. It's horizontal. What equation is that? That's y equals 2, isn't it? Right? But we only want a piece of it. We don't want the whole thing, so let me erase this. So instead of saying y equals 2, we're going to say y equals, and right here we put the 2. And now we need the condition. If what? If x is greater than or equal to 0. Cool?
Yeah.
All right. And now, I mean, that was pretty easy, right? But here's where it gets a little funky when it comes to domain and range. Okay, so the domain's cake. Why is the domain cake? D, and then you can put x equals all real numbers. Everybody sees that, right? Why is that? Because it goes to the left forever. So on the x number line, it goes to the left forever, and it goes to the right forever, and there's no missing values. Perfect. So the domain is x equals all real numbers. Will this graph exist at negative 5? Yeah, just down here. Will it exist at negative 10? Yes, but just way down here, right? Will it exist at positive 5? Yeah, up here. Will it exist at 10? Yeah, up here. So it really is to the left and to the right forever, so that's why x equals all real numbers. Let's look at the range. This is where it gets a little funky, all right? What y values does this have? So let's write down the range is going to be y is what? Y is it all real numbers? Does it exist up here at positive 4? Does it exist at 3? Okay, somebody said less than what?
2. Oh, no, less than 0.
Less than 0 would be the correct one. But if you say, okay, let's say you said y is less than 2. Well, yeah, it exists at 2, but less than 2 would imply a 1. Does it exist at 1? No, there's a gap right here, right? So this is what I would do. I would say y is less than 0. Let's write that down. Y is less than, or no, less than 0, not less than or equal to, just less than 0. Or it could also be y equals 2. Because it also exists at the value of 2. It doesn't exist at 1.9, it doesn't exist at 1 or 1.5, it only exists at 2. So there's two things here, the less than 0 and also 2. Fun stuff, huh? You love it. Okay, now let's practice graphing piecewise functions. So let's graph this piecewise function that we call f of x, and it has 3 pieces to it. So you gotta imagine, let's call this first one, I want to do it in blue, y equals negative 1/2 x minus 2. So where would this cross the y-axis? At negative 2. Everybody put a dot at negative 2. But you know what? If you have a pen, don't do it with the pen. If you have a pencil, do it lightly, okay? Because we're going to have to erase, okay? And I could erase right here. If you're doing it with a pen, just don't do it at all. Just watch, do it later on with a pencil. So it crosses at negative 2, and my slope is down 1 over 2, which would be right here, and then down 1 over 2. And I'm going to use that pattern to go backwards, up 1 over 2 in the opposite direction, up 1 over 2 in the opposite direction. Now this blue line, I would draw it all, but what's my condition? My domain says that the condition is if x is less than or equal to negative 2. So you only want from negative 2 to the left, okay? So you do not want the 0. You do not want over here or in the positive direction. You only want, again, from negative 2 in the less than direction. So from here going that way. Does that make sense? So let's draw our solid dot right here. And you are going to draw it in this direction with an arrow because it does continue forever. So that's the first piece of the 3 on this f of x piecewise function. Now the next one, let's look at it in green. It says f of x equals 1. That's going to be y equals 1. That's easy. Y equals a number. Is that a vertical line or a horizontal line? Horizontal. So you're going to go to 1. You're going to put a dot there. It's going to be a horizontal line right through that value. Now, please don't do that if you have a pen. Do it if you have a pencil. because we're going to have to erase some of it, probably. So this line that I just drew, I mean, that if it was y equals 1, it would continue forever. But I obviously have a piece. What's my domain piece? It says from -2 on the x all the way to +1 on the x. Open dot at -2 and close dot at +1. So I'm going to erase anything that's past -2. So I'm going to erase this over here. And it is an open dot at -2. And it stops at +1, and it's a solid dot at +1. So I'm going to erase everything after the 1, erase that part, and we did say it's a solid dot at 1 right there. So that's a second piece of the 3 pieces on this piecewise function called f of x. And finally, the third piece. Let's do this in blue. So instead of f of x equals 2x, I want to say y equals 2x. So that one crosses the y-axis where? What's the b value of this guy? 0. So it crosses here. And then what do I do from there? Up 2 over 1. So again, if you have a pen, don't do this. It crosses at 0. You go up 2 over 1, up 2 over 1. You could continue going up 2 over 1 to extend it as far as you want. But what's the condition here? X has to be greater than 1. So obviously, you can't have the x being 0, so you'd have to erase that dot. Here's 1, so it begins here, and it's greater than, so it goes to the right, so it does go this way. So here's our last piece, and this is going to be an open dot. So let's put an open dot right here, and it goes this way with an arrow. So we have graphed our piecewise function. Again, this is the hardest part of the entire chapter, probably of the entire 9-week period, right? There's nothing harder than this on the midterm. And the only way this gets easy is with practice. Oh wait, we didn't state domain and range. You know what? The video is already ridiculously long. What's the domain? All real numbers. Domain x equals all real numbers. Don't forget the x, because I don't know if you're talking about x's or y's. And what would the range be? This one's a little bit more complicated because it has. Oh no, it doesn't. I was thinking it has gaps, right? But it doesn't. Why? Because this red line will cover everything from here up. From here up. So this whole thing is going to be from here up in terms of y. So what would that inequality be? Y is greater than or equal to -1, right? Because you're here at -1 on the y, and the whole thing is above -1. So that was pretty easy, actually. I thought there was going to be some gaps, but there was not. Number 2. All right. I know. You guys need to shake it off. It's exhausting. Long video, long lesson. Let's call this first one y equals 3/2 x. So where does it cross the y-axis? 0. If you have a pen, don't do it. If you have a pencil, you can do it because you're going to have to erase. From that point, you go up 3 over 2. And you could continue to go up 3 over 2. And you could use that pattern backwards. So you could go down 3 over 2 in the opposite direction, which would be right here, and down 3 over 2, which would be over here. Now, we want the condition that it says x is less than or equal to -2. So where's -2 at? -2 is right here, and less than would be this way. So you want this dot and to the left. So you want this part of the graph. You don't want anything else. So we're going to have to erase the rest. And it is a less than or equal to, so that's a solid dot going this way. So that's the first piece of the 3 on this piecewise function called g of x. Let's go to the next one in blue. That's going to be like if you had y equals x plus 1. Where would that one cross the y-axis at? 1. At 1. And what do I do from that point? What's my slope? Up 1 over 1. Up 1 over 1. And you could extend it however far you want in both directions. Again, don't do this with the pen because you're going to have to erase. What's the condition? If your x values are from -2, that's an open dot at -2, all the way to +1. So -2 is right here, and that's going to be an open dot right here. So let's change that to be an open dot. and it goes all the way to positive 1. Positive 1's over here, and that's going to be a solid dot. But you're not going to do the rest. So let's erase the rest. And there's your piece right there. From this open dot all the way to this solid dot. And last but not least, we're going to look at the y equals 4. Y equals 4. And that's an easy one. It's a flat line at 4. A flat line at 4. And of course, you're going to have to erase. Whoa, that's really crooked. Hold on. You're going to have to erase this, so don't do it with the pen. And the condition is from 1 to 3. So from 1, here's 1, to 3, here's 3. So from 1 to 3, you're talking about just this piece right here. So that would be your final graph. It doesn't continue that way forever. This is your piecewise function. And I'm going to stop right there. I'm not going to do the domain and range for that, because this video is way too long already.